Okay, hello and welcome to today's event, everyone, on BI and Dynamics AX. I'm Jason Gumpert from msdynamicsworld.com, and we're here for a second session exploring the present and future opportunities around BI technology. And we're joined again today by Carolyn Nersessian, Senior Data Scientist at Arbela Technologies. It's great to have her back. As we get started, please know that we welcome your feedback and questions during today's event. Feel free to use the Q&A block or the chat that you should see to the right slide of the main presentation area at any point to ask your questions. You should also see a media viewer block over on the right, and that is just a tool for you to use if you want to quickly request a follow-up or a separate discussion with Carolyn and the Arbela team beyond today's event. So without further delay, we are going to get things started. I'm actually going to have Amir Kosniati of Arbela start us off. Amir.
Thank you, Jason. Just a confirmation that you guys can hear me okay?
We can.
Great. Thank you all for joining. This will actually be part 2 of a series of BI webinars we're holding, and we've made it a little bit intuitive. If you did miss part 1, we can send that recording at the tail end of this. But if you are new to the webinar series, today will work just fine for you, and you guys will be able to understand the topics that we have planned for you today. So if you do have any questions, as mentioned, this is an interactive session. Please feel free to submit them in the Q&A pane, and we'll address them as our moderators will be reviewing. So before we start, a little background on Arbela Technologies. We were founded in 2002 by ERP and supply chain veterans, 2 of which were part of the original DamGuard team prior to it coming over to the U.S. We've been the leading gold certified partner since 2004. We're also silver certified in Dynamics CRM and Microsoft Azure. We're a global company. We have offices all over, mainly headquartered in Irvine, California. Our European headquarters are in the United Kingdom. We have offices spanning from Bellevue, Washington to Dallas, Texas, Atlanta, Georgia, and even in Denmark. Arbela is a large, complex, multi-company organization. We handle everything from multi-currencies, multi-sites, multi-languages, and shared services are just part of the package of our implementations. Our vertical experience is very extensive. We're manufacturing and supply chain experts. Also distribution, global financial management are part of our toolkit in that realm. As mentioned, full AX and CRM implementation partner, everything from sale to post-go live with our managed services and support desk are just a part of our toolkit. We have 4 ranges of ISV solutions that are AX7 competent. One of them we'll mention today, Arbela Data Insights, which is both for AX and CRM, and then we have 3 other solutions that are tailored towards Dynamics AX. One of which you may have heard of is the Arbela Security Manager. It is tailored to both security management and then auditing compliance. It streamlines all the services around that as well. And then we also have a master data centralization solution for companies with multi-sites, multi-locations. And then we have a one-step consolidation solution that takes the standard 14 steps in the financial module and can consolidate it into one quick one. And if we can jump to the next slide. Just some awards and recognitions from Arbela. We're gold certified, as mentioned. We're part of the TAP Partner Program, Advisory Board, AX UG board members, Partner Connections, and Dynamics World contributors with Jason and Adam. This year was a prominent year for Arbela, especially in the Orange County community. We were listed as the 2nd best place to work, and we're also listed as one of the top medium-sized companies coming in 2nd place with that. And a handful of our team was at an award ceremony where we came up as runner-ups in the OC Tech Alliance, both for Outstanding CEO and Outstanding Tech Company. The next slide, please. And then without further ado, I'd like to introduce today's presenter, Carolyn Nersessian, the PhD, our Senior Data Scientist. And with that, the floor is yours, Carolyn.
Hi, everybody. Welcome back. If you weren't part of part one, you can get that recording as Amir mentioned, and I'll cover just a little bit of what we talked about there and then move on. Okay, so today's agenda will be starting by looking at business intelligence and data warehousing, which is a little review from our last webinar, part one. Then we'll go through the 6 levels of business intelligence in terms of what types of things you can do to get strong results from your data. I'll introduce a couple of case studies for how different types of business intelligence applications can work. I would like to demonstrate a forecasting model, which I'll use in the R platform. And then I thought I might have a little bit of fun with you guys in how election prediction is done. So I'll go through a quick demonstration of election prediction model also in R. And then I'd like to show you some examples of Azure machine learning, so some tools that associate with Microsoft products like Power BI, and which is the platform that Arbela Data Insights uses. And also, please feel free, if you have questions at any point, just to type right in, and that's not a problem at all. So feel comfortable asking questions at any point. So I'd like to describe business intelligence as an approach, rather than to just define it as a single thing or composite of certain activities. It's the approach to how you deal with your data. And what businesses essentially need from a BI application is a full picture of what's going on in their organization. They want to be able to describe and diagnose past and current performance, predict future performance based on their current data and historical, and then also blueprint prescriptive action and outline the implications of each of those options so that you can get an idea of what choices will have what ramifications or results if you choose to take them. And business intelligence, particularly machine learning and analytics portions of that, offer a lot of ways to get good information from your data prescriptively and predictively. And as an approach, BI uses a variety of technologies and standardized processes to collect and structure data, to analyze that data and then convert that data into results or information, and then to present that results of information that you've analyzed from all of your data to improve your business decisions. And of course, the goal is that all of these activities convert raw organizational data that might be distributed through many different applications in your company into meaningful and actionable information. And most people might recognize this if you were here from the last part, but the process is really where, for business intelligence, you take your business operations data, all of your transactional data from an AX system or ERP, of course, CRM, flat files, and so on. You generate that data, that raw data, structure it, clean it, and present it into a data warehouse, which is my recommendation, although not all BI applications require that. And I'll explain a little why I support or believe that a data warehouse is an excellent option. Oops, I clicked when I shouldn't have. And then this is the big part. BI applications come in for analysis, monitoring, forecasting, predictive and prescriptive applications. And this is where you take that raw data that's been cleaned and transform it into meaningful results by using reports and then monitoring what's happening within your data warehouse or your organization. And then management can take action on those results, and the information can be used to increase profits, reduce costs. Now, I mentioned in the last talk about the importance or the benefits of using a data warehouse. So data warehouse is a centralized store of organizational data, and it is specifically optimized for reporting and analysis. It uses an extract, transform, and load process, and that process is very important because it copies your data, cleans it, loads it so everything is consistent, it's at the same grain or level. It allows you to store metadata creation, or it allows you to create and store metadata so you can track what's happening within your data warehouse and your operations. It can give you a window into your historical organization's activity because it provides one version of the truth. And it also allows you to have a certain amount of redundancy because of that historical information, and that gives you multiple views of information within your organization. Of course, the data warehouse is designed specifically to support BI activities and applications. It tends to be easier and more efficient for querying, and it reduces your resource kind of tug-of-war if you were to try and do the same sorts of things within your operational systems. And nowadays, when you load new data into your data warehouse, you have a lot of different frequency options. So you can organize the data warehouse to update information from your transactional systems in real time, moment to moment, or you can set it up to do updates or loads every hour or once a day or so on, depending on the needs of your business. I also talked a little bit about Arbela Data Insights last time as a business intelligence solution. And the Arbela Data Insights product is on the Power BI platform. It is an online software service, and it's designed to help you really easily and quickly execute self-service BI. So essentially, if you have AX or CRM, you can essentially plug this in and get it started to working within an hour. So, it lets you analyze and visualize reports, provide dashboards, and the main components of Arbela Data Insights are pre-built customizable dashboards. We have over 2,000 development and testing hours into these KPIs and metrics and reports that we set up, and we've always set up all of these things in consultation with experts in their field to make sure that if you are looking at the finance module for ADI, that you will have the right metrics that they will be calculating correctly. And then finally, you also have the data warehouse, which is built against AX and CRM, but that can also be modified or can be adapted to incorporate flat files, legacy information that you may have on other systems. And so for Arbela Data Insights, I also wanted to mention to those of you who may not have seen it, the email go out, but we are offering a 14-day trial for Arbela Data Insights. You can try it out and see if it fits. And the modules that we are trialing are sales and invoicing, procurement and purchasing, and finance right now. And you can contact Amir, who was speaking earlier. His details will be at the end of this presentation as well. So I encourage you, if you're interested in looking at a reporting tool that allows you to access data via a data warehouse and an AX system, to contact Amir and give it a try. So on to what we're really focusing on this particular webinar. So the benefits of solutions like ADI and a data warehouse and BI solution as we have set up is that you have access to extraction logic. You're able to actually see how information is taken out of your organizational systems, ERP, your flat files, aggregate your data, clean it. You have access to a data warehouse. And here's the big part. Data warehouses designed in a format like Azure SQL, at this particular point, allow you to focus your data in several different ways. So if you're interested in looking at reporting information through ADI, for example, or a Power BI option, you can funnel your data from your data warehouse right into a reporting module. But you can also access your data using a variety of machine learning tools, which I'll talk about a little bit today. So for example, if you're interested in doing some forecasting or predictive analytics, advanced analytics, setting up some benchmarking against your data, you can actually access your data warehouse directly through statistical programs like R or R language, Python, HD Insight, for example. For Spark, you can set up R on the the Microsoft Enterprise R server. You can now access your data directly through that. And why is that important? A lot of other reporting applications today, like some of the larger ones, like Tableau, don't let you access your data with a variety of different ways with respect to doing advanced analytics. So Tableau lets you access data, for example, using the R program by way of Spark. But Spark is limited in terms of the library or the actual algorithms that you can use to do analysis. So you only have a few options to do any kind of statistical analysis, basic options. Whereas if you have a more open data warehouse like what we have with ADI, you can access your data using a wide variety of machine learning applications, R, Python, SAS if you still use SAS, SPSS, Strata, and so on. So any types of many types of machine learning and statistical tools. So that gives you a lot of options to really get information from your data. And so what kind of information am I talking about with respect to data? Well, this figure looks at the complexity of BI from low to high as a function of its business value from low to high. And last time in our webinar, we talked about the first three sections here, reporting, analysis, and monitoring. And that's really where most applications today are sitting in terms of what types of analytics that they present to their audiences. You can do a lot of summary and descriptive statistics. You can get an idea of what's happening, what happens with your data, why it's happening from a descriptive standpoint, and you can often have a monitoring access where you can view what's going on with your data in real time or relatively close to real time. And that's the ADI reporting tool functions in this, Tableau functions within this, and many other applications for reporting usually fit within this area right here, if you can see my mouse. Now, what we're going to be talking about today are the more advanced analytics that are options for how you can work with and use your data. So forecasting, predictive, and prescriptive analytics. And as you can see, as you get into those types of analytics, the complexity increases, but the business value also increases quite substantially. Forecasting, a lot of companies already do from a manufacturing standpoint, but a lot of the models can be quite simple, so you can expand and get a lot more detail in your models with forecasting using a data warehouse and more advanced analytics. You get an idea of what, based on your historical data, what might happen, and based on what happened, what's likely to happen. And that's very important, so you can look at patterns and trends based on the behaviors and the relationships of your data, and you can actually access the Internet of Things. There's so much free information out there that you can access, and you can apply that to your existing data to get information about why or what might be going on with respect to patterns and trends that you're seeing in your data. Predictive and prescriptive overlap a little bit, but the real separation between prescriptive and predictive is that prescriptive machine learning algorithms will give you suggestions or options of different types of strategies or actions that you can take and what types of things may happen or are most likely to happen if you choose those options. So prescriptive and predictive look at potential outcomes based on complex interactions. What will happen? When will it happen? Why will it happen? And when you get to prescriptive specifically, if you do this, what's most likely to happen? All right, so just to take a quick break, I thought we would play just a little game for a second. And a lot of people don't know why we use analytics, why statistics is so important. And it's because of how our human brains work. Our human brains don't deal with probability very well. Our intuition about probability is usually wrong. So I have a few little games throughout this demonstration that will let you kind of see that within yourself. So just take a moment and think. You will win a prize, whatever prize you want, although I don't really have any prizes, but you can pretend. You'll win a prize if you pick a red jelly bean. And you can try to pick that red jelly bean from one or two bowls in front of you. The first bowl is a small one, and it has 9 green jelly beans and 1 red jelly bean. And the second bowl is larger, and it has 93 green jelly beans and 7 red jelly beans. If anyone wants to put into chat or say what they might choose or select, you're welcome to. I'll give you a second to think about it. And when it really comes down, when most people end up making the wrong choice, most people end up choosing 2. And you can see that if you were to try and select the red jelly bean from that 7 red jelly beans and 93 green jelly beans, you only have a 7% chance of picking the red jelly beans. So bowl number 1 is the right choice. But a lot of people get intimidated by having fewer options, even though there's a 10% chance of picking that red jelly bean. A lot of people even know that the chances of winning are higher with the small bowl, but they still choose the larger bowl just simply because it seems like there are more red beans available and it just seems like a better option. So our brains are really not evolved to deal with probability sensibly. And most people make an illogical choice, even when they know the answer is right. And analytics, when you apply analytics to data or to probability or the likelihood of an occurrence of something, those analytics actually help you deal with probability logically and offset how our brains work against us in that capacity. Oops, I'm sorry, I accidentally clicked something and got a box in the way. Okay, so data is power, and data is everywhere nowadays. Right now, the last time I looked, which was I think about 5 months ago, there were 2.7 zettabytes of electronic data in the world. That is 22 zeros. 22 bytes worth of information. That's like storing 200 billion HD movies. And new data is produced at an exponential rate, like literally doubling itself. It's amazing the amount of data that is being generated out there. On top of that, the processing power of computers is increasing. For example, decoding the human genome originally took 10 years. Now it can be done in 1 week. That's the human genome, which is a massive amount of information. It's also known that companies will be investing more than $120 billion on analytics, hardware, software, and services. As a matter of fact, IBM has invested over $20 billion since 2005 to grow its analytics business. I know that Uber has recently started it, or actually has from the beginning, and then more recently started to invest quite heavily in BI and particularly machine learning applications. Salesforce is another one. So data is everywhere, and it's about time that people start to actually harness it and use it. There's so much information on the Internet of Things. There's so much information that you can use with your own organizational data to get information about how to move around within changing business climates and target customers. So I'd like to give you a quick case study. One of the benefits of machine learning and show you how it can actually help companies. There's a company called Building IQ. It's a software as a service company based out of San Mateo, California. And the company is designed to monitor and adjust heating and air conditioning environments to improve the efficiency of how those things are run in commercial office buildings and reduce the overall cost. They use an advanced machine learning model that applies historical data, that's use data from the building, so what the heating, what's the HVAC system information is telling you in terms of how the climate changes throughout the day. They take external information from the Internet of Things using weather forecasts, and of course they get real-time data streaming from the HVAC systems and energy cost data. And they perform this algorithm to determine and to automatically change the settings in terms of how the air conditioning or heating functions within the parameters selected by the organization. So if they want it set at 67 degrees throughout the day, this company will monitor it and ensure that that's where it stays throughout the day. And the algorithm is just, by the way, based on MATLAB, MathWorks MATLAB, which again, if you're using a reporting platform like Tableau or Qlik, you are not going to be able to necessarily access your data through a machine learning program like MATLAB MathWorks, which is why you really want to have a data warehouse access to your AX data in particular, access to that through some sort of resource like a data warehouse that allows you to access that data from many, many different platforms, statistical platforms. And Building IQ has documented savings for building operators of between 10% and 15% off of energy consumption, which if you think about an entire building, that's a huge amount of savings in terms of energy consumption costs, and just good on so many levels, saving the company, environmental savings, and so on. So that's a good example of how machine learning algorithms can help businesses. And it's also a good example of why you want to be able to access your data in the most versatile ways possible. Another data-driven company I'm sure you are all familiar with is Netflix, a highly data-driven company, probably one of the first. It had a Kaggle competition quite a few years ago to create a recommender algorithm that can, so that when you open up Netflix based on your account and your viewing history, you'll get a presentation of movies or television shows that you're most interested in. And then the more that you choose movies, the better the information is in terms of selections. But they also use it in many different ways. The company in itself has about 74 plus million subscribers worldwide. They collect massive amounts of data from their users, but also from the Internet of Things. For example, Netflix looks at 30 million plays a day, and that includes pauses, rewinds, fast forwards, the time of day, what device is being watched. 4 million ratings by Netflix subscribers, searches, 3 million. They also look at metadata descriptors like tags that were inserted by viewers, commissioned to describe the talent, action, or tone, so people paid so they can get that information. And there's 33 million different versions of Netflix, which is pretty amazing. So they make better decisions about which television series to buy, in addition to what they show you, to keep available to people and to develop original shows based on all of the data that they get from users in the Internet of Things. So they don't just pick movies and television shows at random. So when they decided to present or create that $100 million show, maybe not all of you have seen it or liked it, but the show House of Cards, I think that Kevin Spacey was selected, and it was not selected simply because it had a great shot or because the British version was really good. It was selected instead based on other criteria. So people Netflix looked at how many people on Netflix watched movies like The Social Network or films by David Fincher like Fight Club, Seven, Gone Girl, The Girl with the Dragon Tattoo. They looked at how many times people watched films with Kevin Spacey in it. American Beauty, The Usual Suspects, LA Confidential, Horrible Bosses. And they basically decided to build the show using I thought this was funny when I first read it, but using the director David Fincher and casting Kevin Spacey in it, particularly because those were so highly selected by audience members. So before greenlighting the show, Netflix knew a lot of users watched David Fincher directed movies like The Social Network. They also knew that people watched the British version of House of Cards. It was highly popular. And those who watched the British version of House of Cards also watched films with Kevin Spacey in it and films directed by David Fincher. So that is how they decided to narrow down and choose that particular show. And in the end, The House of Cards was one of the most watched shows on Netflix. And the company had a great idea it would hit. It knew that it would be a hit before it even started filming. And these types of BI strategies are also now being applied if you use Amazon Prime and Hulu as well, because you'll notice that a lot more organizations are creating their own shows. So that's one way to have a look at how businesses can use. I know that might be a little abstract for the general business, but you can kind of apply how you can use data to really get a lot of information and to make business decisions. So the core job of analytics, we know that data is power and it's everywhere, and the core job of analytics is to help companies gain insight into their customers, to reduce business costs, streamline and improve processes. Companies can then optimize their strategies, whether they're marketing, purchasing, inventory, and then deliver better products. So what I'd like to do is show you a quick demonstration of a forecasting model in R. And I know for some of you who may not be big statistical people, all of these tiny words and numbers might seem intimidating at first, but I will go through it with you. So, and by the way, I'm just using a regular R application in data that I'm taking from my desktop. However, it would be just as easy for me to download and install a package specialized to access data from the Arbela Data Insights data warehouse and start to analyze and munch data directly from that, because there are a lot of packages that allow you to access your data through SQL resources. So what we're going to look at is data that looks at the median house value for 506 neighborhoods around Boston, Massachusetts. And so when I open up this screen, you can see this is well, for me and anyone who's a statistician, this probably makes you smile. But most people will see something like this and be like, oh my God, look at all those numbers, and I don't want to look at this anymore. But this is the type of data that you'll see. And consider that if you wanted to, for example, take a new product from one of your organizations and enter a new market, this is the type of information that you might be looking at. For example, you wanted to introduce a new electronics product to a new city that was similar to another city that you were looking at. You might look at information from the Internet of Things in terms of weather or the average median income, how much people spend on electronics, how many electronics they own in their home, and so on. And you can use information like that to determine if that market would be a good place to place your new product. Now, the type of variables that we're looking at here are predictor variables, or what are called, relate to the 506 neighborhoods in Boston. So, for example, we might look at the average number of rooms per house. You might look at how old the houses are. Another one that might be interesting in terms of affecting the median level of a house price is the percentage of houses that might be viewed as having low socioeconomic status, or the per capita crime rate. You might also look at factors like pollution. Nitrogen oxide parts per 10 million, for example, influences air quality quite substantially, and high levels of nitrogen oxide might indicate that the neighborhood is in an area near industry, and so on. Or you might be interested in looking at teacher ratios by town or neighborhood. All of this type of information, if you apply that to, say, a business application where you were to try and enter a new market with an electronic product, all of these types of information are often available for free through governments or through other websites on the Internet of Things, and you can use them in your algorithm. So I am just going to set up a little general linear model, and I'm going to look at how does the median value of house prices change with the percentage of houses that are of low socioeconomic status in a particular neighborhood. And I'm going to run that algorithm or that model. And the first thing you see over here, all these tiny numbers, we can look at the intercept and LSAT. And for those of you who are, or LSAT, which is the percentage of low-income houses, and for those of you who are not familiar with this type of information, what it's basically telling you is that the median value of owner-occupied homes is $34,550, and that the median value essentially decreases by $950 per percent of houses with low-income socioeconomic status. So that's helpful information from a predictive standpoint. So you can say if you were purchasing a house in a market and you noticed that there was a high number of very, fancy, well-maintained houses around, that chances are the median value of the homes are going to be much higher. Now, of course, we can also look at this data another way. And what you're looking at here, again, I know tiny numbers, don't worry, I'm not going to leave you in the world of tiny numbers for long, but I wanted to give you an idea of what types of things statistical analysis is involved. So in this case, I'm now looking at a predict function, and I've essentially created what you call a confusion matrix. And this is to give me a better idea of the accuracy of the model. So this matrix, in this particular case, for example, predicts that the median value of a house with a 95% confidence interval around that house. So essentially, if 5% of the houses, because that's the way I set up the model, I bundled the percentages, if 5% of the houses in your neighborhood are of low socioeconomic value, on average, you can see right here, the house value will be between, this is your confidence interval right here, I apologize for stumbling on this, but on average, the median house value of your house will be $29,000 to $30,600. I know this data is probably from like the 1950s because that's certainly not current today. And then also you can get an idea of so that's actually pretty good accuracy. You have a pretty small confidence level where you can be 95% sure that the values will fall within that range. But really, this isn't how you want to look at data if you're a layperson, but you really want to look at data as visually. And so here, what we're looking at is a scatter plot of this information, and we're looking at the median value per 1,000 on the x-axis and the percentage of low socioeconomic status houses on the y-axis. And you can see here that there's a nice negative linear relationship, which we just spoke about when we saw in those numbers. But here you have a little bit of a problem. If you notice how this, for anyone who's familiar with data, if you notice how up here that's kind of curving up, this indicates that the relationship is not entirely linear. And because we're using a general linear model, what that essentially means is that this model may not be predicting as accurately as we would like because the data in the model isn't fit correctly. And instead of using a linear regression model, we will probably want to try something like a decision tree or a decision forest, or something that can mediate or deal with non-linearity in the data. And of course, ultimately, you're going to want to run a more complex model, which would be a multiple regression, which is going to give you more information about how all of the variables interact. But again, you're still going to have to deal with that linearity problem. So I hope you can see in this particular example in R that, go back to the webinar, in R that predictive analytics and forecasting models with statistics are often more complicated than people realize. And when you use a model like that, you may get what looks like really good results, but those results may not actually be as accurate or as viable as they look on first glance, because the data doesn't fit the model appropriately, which is why when you have somebody work on your analytics, your forecasting models, your predictive models, and your prescriptive models, you really want to make sure that you select somebody who knows what they're doing in terms of data analytics. So here's another jelly bean game. Hopefully you're not tired from the first jelly bean game, but it's always good to touch base and remember how our brains work. So in this game, you again win a prize if you pick a red jelly bean. But this time, you cannot see either bowl. And you can try to pick from the bean from one of two bowls. One of the bowls you know has 50 green jelly beans and 50 red jelly beans. You know it. And the other bowl has 100 green and a bunch of red jelly beans, a total of 100 jelly beans, both green and red mixed together, but you don't know what the quantities are. So which one would you choose? Well, in most studies, almost everyone chooses the very first bowl, even when the question is asked in reverse. And what this comes down to is that we have a hard time dealing with ambiguous situations. They make us uncomfortable as humans. Our brains are not evolved to deal with them. So we avoid thinking about ambiguous situations. And so choosing from the first bowl requires that you think about probability, right? It changes randomly, choosing one bean or the 50-50 bowl. So if you choose from the second bowl, it's actually much more complicated because it combines both probability and ambiguity, which makes us very, very uncomfortable. And let me say, how often in the business world do you come across situations where you're looking at the probability of an event and there's a lot of ambiguity around it? And so just to let you know that our brains, and this is physiological, different parts of our brains deal with risk or probability and ambiguity. And ambiguous situations actually activate fear centers in our brain and decrease reward center activity. So you can see that we have this physiological human barrier to our dealing with ambiguous situations and risk probability, which is why statistics is so important, and it really helps us deal with ambiguous situations more logically and efficiently. So I'm just going to step to our election forecasting model and show you a little bit about how we will train a predictive model and then test that model, which is going to allow us to, or at least the preliminary step of organizing a machine learning prescriptive model, and then also build up on accuracy. And this is quite relevant with the presidential election coming up. Predicting the winner before any votes are cast using polling data is often how election forecasting is done. In U.S. presidential elections, most of you know who are from the U.S. or have been here for a little while know that generally there are two competitive candidates. It's Republican versus Democrat, bipartisan. And then probably if you remember back to your civics lessons in high school where you wanted to stab yourself in the eye with a fork because they were so boring, but you remember that 50 states each have electoral votes based on population size. For example, California has the highest number of electoral votes at 55, and some states have as few as 3 votes, again, depending on population, and that changes when we conduct census. And the candidate with the most electoral votes, not popular votes, wins. In this particular example, we're going to look at data from Real Clear Politics. It's polling data that was collected in the months leading up to elections from 2004, 2008, and 2002. And so this is an example of a model that's being trained off of historical data to better predict, say, the upcoming election. The information that we have is the state, the year of selection, and the variable that we're interested in seeing whether or not it's affected by Republican versus Democrat is a binary variable, which is Republican wins the state, it's 1, Democrat won the state, it's a 0. We also have some independent variables, and these are the variables that we're wanting to know whether or not they cause an impact on our binary variable, or they cause a change on that. So we're looking at survey data from 2 large surveys in the U.S. Rasmussen and Survey USA, and the data there is the percentage polled Republican and the percentage polled Democrat subtracted from each other so that you get the percentage of voters who are likely to choose Republican over Democrat. So for example, if it was 6% Republican, you have 6% of the voters that choose Republican. All the polls that, and then we also are looking at polling data for the predicted Republican winner minus polls with the Democrat winner, so a whole variety, I think it was about 50 different polls, calculated together to see how many polls actually predicted the proportion of Republican, proportion of the Republican presidency win. So in this particular case, I pulled this polling data in from Excel. And the first thing that I did was actually clean up some of the data because it has some NAs in it, which we don't need to do, but that's what this information is here. NA1 is used to using R. And I'm setting up a training set of data and a test set of data. So my training set has data from the years 2004 and 2008, and my polling set has data from year 2012. And the first thing that I want to do when I'm looking at a model like this that I want to train is I want to get a baseline idea of accuracy. So how accurate is this data just on its own? And so I didn't set the feed. And so in this data, you can see, if we look at this, you have your 0, 1, we have a confusion matrix. You have your -1 and 1. And basically here it's saying that 35% or 35 of the observations correctly identified the Democrat as the winner. 37 of the observations over here correctly identified the Republican as the winner. And 3 got it entirely wrong over here. And then there were 2 unknowns, observations that were just inconclusive. So that's our baseline data. That's what we want to beat in terms of our the models that we set up. So I'm going to set up a general linear model comparing Republican against just one particular independent variable, and that's the prop R, which is a series of polls. And you can summarize that. See this information. And probably one of the things I'll just point out over here is the Akaike information criterion, which indicates how well the model is selecting variables. And you can see that this model is okay, not great. We're going to look at the confusion matrix. And so this particular model predicts 45 times correctly that the Democrat was selected, and 51 times correctly that the Republican won. And we have 4 errors overall. So that's actually an improvement to our baseline. We might want to just see if our model can improve more. Now set up a prediction and then another confusion matrix. And in this model, I've just added the survey information from Survey USA and then the difference between all surveys out there. And I apologize. I didn't run my imputed. I was not happy. You know, it's always like this when you're doing a demonstration. It always has to fail. It's just because I haven't read in the data correctly, and I should probably just restart the program and the model. But instead of doing that, I'm just going to jump down to our testing set data. So the second model that I was looking at was probably a bit more accurate than the first model. And so what I want to do, and what most people do when it comes to machine learning models, is that they're interested in improving the accuracy of the model. And in this particular case, when I apply all of that data to a test set, you can see that the accuracy has actually improved quite a bit. We only have 1 error. And if we want to identify what that particular error was, we can actually look at that information, and you can see that the one error in our model where our predictive model is failing is from the state of Florida. You probably remember that sometimes Florida gets a little weird, and that was where the Rasmussen survey estimated a 2% lead survey, USA predicted a tie, but most surveys predicted that the Republicans would win. So anyway, this is another example of a machine learning model that you might use for predictive analytics. And then the last thing I just wanted to show you in terms of what types of things are out there are machine learning models that are associated with Azure machine learning. Again, all of the things that I'm showing you interact directly with a data warehouse. And this what you're looking at here is Azure Machine Learning Studio, which is through Microsoft. This is kind of an interesting program. All of these little squares or modules here are essentially designed to either clean up your data, separate out your data, split it into testing and training sets, or there are presets, for example, calculations like boosted decision trees. So you can filter your data through programs like this and visualize your data and get the same types of accuracy, mean or absolute standard errors and information through models like this, accuracy and so on. And this type of a machine learning model can be designed to interact with your AX data and continually learn from itself. And this is an example of clustering data. So there are lots of different models out there, and if you have somebody working on your data who knows what they're doing, they can build your own machine learning model. So just to get back on focus, most companies are going to benefit in terms of using their data or using a data-driven approach to your business. Pardon that typo. Data science as a service is a lot of options out there. A lot of organizations are hiring data scientists. There are also a lot of organizations that offer data science as a service, like, for example, Arbela. So you can, with data science as a service, use supervised machine learning techniques. And a lot of those supervised machine learning techniques, and all that means is that you have your data and it's your organizational data that is essentially making that model or driving the prediction of that model. And so there are all sorts of machine learning techniques out there that can be applied to organizational data that reduce customer attrition, for example, looking at historical behavioral data to predict the likelihood of churn. There are a lot of models out there for acquiring new customers, lead scoring, optimizing markets, improving customer service. For example, there are models that prescribe cross-sell products or optimize pricing and product development, or serve customers better through predicting demand, services, and products, predicting what the demand will be for a service or a product, and predictive resources by prioritizing tasks. And we saw the Building IQ does predictive maintenance, but there are a lot of things that can be targeted to individual organizations or customer segmentation. So when you're looking for a company or an organization or a person to be working with your data, if you think about how much money you can save as an organization, you really want the person who's working on and who's analyzing your data. And I'm not so much talking about reporting, monitoring, and basic descriptive analysis, but I'm talking about forecasting, prescriptive, and prescriptive analytics, because reporting is more of a self-service BI tool. But if you really want to harness what your data has to offer, you want to make sure that you look for an organization or people who have the specialty skills required to produce optimal results. You want somebody who has a strong background, or an organization that has a strong background in statistical theory and application. They should probably have a background in multivariate calculus and linear algebra, and they should have the power to think like a data scientist. So a lot of people confuse developers and data scientists. Data scientists and data science as a service organizations are not just developers. They also have a lot of statistics. So if you're sending or looking for an organization or interested in starting to build analytics or more advanced analytics on your data, definitely make sure that you look into an organization that has these types of skills. And again, I just wanted to close with our Arbela Data Insights ADI 14-day trial. So that's our reporting. So I've given you a few little images of the reports that you have to offer. That's the associated data warehouse that you can interact with. and the modules are sales, invoice, and procurement, and finance, and you can contact Amir. So are there any questions?
All right. Well, thank you, Carolyn. And yeah, to anyone in the audience, please do enter your questions now through the Q&A block that you should see to the right of the main presentation window. Carolyn, we did get a few guesses earlier on the quizzes that you had, and people did go for both options, like the large bowl versus the small bowl with jelly beans. Let's see here. So one question that's come in: what advice? So this person says there's no denying the value of BI, but what advice would you give with regard to the steps to take in order to ensure that the data being entered is accurate?
Yeah, so that's a really good question. And if you're talking about accuracy from the AX platform side, I know that there are a lot of things that you can set up, require fields or drop-down menus that can assure that your data is clean. However, when you're talking about pulling that data from AX, the extract, transform, and load process that's associated with the building or the preliminary status of building a data warehouse is the point where you actually can clean up your data, make sure that it's very, very consistent, and that all of the information that's stored in your data warehouse, which is this historical storage space that never changes, is consistent, clean, and accurate. So that's part of the ETL process. And if you were to do that yourself, you would have to find somebody who had background in terms of ETL, but there are a lot of organizations like Arbela or like I think there's consultants also who allow you who will actually set up your ETL process and into your data warehouse. I hope that answered your question. But the important thing is that you need to transition your data from AX or wherever it's coming from into a solution that will clean it before it enters the data warehouse, and then once it's in the data warehouse, it will always be perfect.
All right, great question. I'm not seeing any others right now, so we can begin wrapping up. Well, Carolyn, first let me just say thanks to you for presenting so much interesting stuff today and taking us through all the different components that you showed off.
Thank you for having me, and I hope it wasn't too much or too little. You never know.
There was one more follow-up question. Again, getting back to the idea of data from AX, is it ever realistic to think that that you can ever get the data right at the source, that being like within AX?
I think when you have so many people inputting transactions, because usually any sort of an AX system, you may have hundreds of people or even just 5 people entering transactions, you're always going to encounter some level of error. So I don't know how to fix human behavior. I wish I did. But I do know that again, why I emphasize the data warehouse is that solution in and of itself can mediate the process, or that can mediate mistakes that are made on the operator level. And that's an automated process. So once you have things set up, information just gets filtered, cleaned, and brought into your data warehouse. So no, and yes, that's why having that ETL process in the data warehouse is such a good idea. I recommend. I hope that answered the question.
All right, excellent. Well, we will start to wrap up here. There is a very brief survey that we would like you and the audience to look out for as you depart today. It really helps give us feedback on your experience, and I know our presenters always appreciate that. With that, I think we are ready to wrap up. You have Amir's contact information on the screen there. Carolyn, anything else you wanted to add?
No, thank you so much. And if you're interested in discussing any sort of analytics options for your company, or if you're interested in a demo of Arbela Data Insights, please contact Amir, and we can do a demo for your organization again, or you can look at the previous webinar. And thank you so much for joining us.
All right, and that concludes today's event. Have a great day, everybody.
Take care.
Thank you.